All right, guys, so we're going to start our notes on solving compound inequalities. Now that we know how to solve and graph inequalities, we're going to look at to solve and graph compound inequalities. Okay, and there are two types. The first is called OR, and for OR inequalities, there will be two separate inequalities to solve. Okay, you're going to solve each one individually and then graph both of them on the same number line. Okay. For OR inequalities, there's two separate inequalities to solve. Solve each one individually, graph them both on the same number line. And these OR inequality graphs will have arrows that point away from each other. Okay. All right. So let's look at an example. Now here we have two separate inequalities. Okay. So for the first one, is simply add 4 to both sides, and you get x less than -3. For the second one, you just divide by 2, and you get x greater than or equal to 6. Okay, so now I'm going to graph, and I'm going to use red to graph. So for the first one, you have x less than -3. So I know at -3, there is an open circle. Okay, because it doesn't have the equal to part in the inequality. And it says x less than that. So that means my line is shaded to the left like this. Okay. Now for the next one, this is x greater than or equal to 6. So that means the equal to part means there's a closed circle at 6. And the fact that all the x values are greater than that, that means this is shaded to the right. Okay. And that's what the graph looks like. Okay. Again, you have arrows that point away from each other. Now for interval notation, all right. So for the first part, we're going to have two separate parts for our interval notation, two sets of brackets and parentheses. Now we know reading the graph from left to right, this part of the inequality, it starts at -infinity. And we know that parentheses is used for -infinity. And it goes up and it stops at -3. But -3 is not included because of the open circle, so that means I use parentheses here. And then there's nothing between -3 and 6. But then it starts again at 6. Closed circle means 6 is included, which means I have a bracket here. Okay. And then the arrow keeps going all the way to positive infinity. And again, whenever we see infinity, we have a parentheses. And that's how you do an OR inequality. Okay. And you'll see the word OR in those types of problems. Okay. Now, the second type is called AND inequalities. Okay. These will appear as one problem, but it has two separate inequalities in it. Okay. And there are a couple ways to solve these AND inequalities. All right. Let me move that over so you can see the whole thing. Now, you can break up the two inequality parts, I guess, if you want to call it that, into two separate inequalities. So it's going to be one again, okay? And this will make more sense when you see it. They'll appear as one problem, and you can break up the two inequality parts into two separate inequalities. Solve each one individually and then graph both on the same number line, just like we did before. That's one way to do it. Another way to do it is you can solve the inequality all at once, talking about the AND inequality. You can solve it all at once. And the key here is that everything that is done must be done on each side of both inequality symbols. Okay. And when you do that, it's probably easiest to work from the middle out to the ends. And again, this will make more sense when you see it. Okay. And inequality graphs will have, they don't have arrows, but they'll have their shading. How about we'll have shading that points or intersects, or however you want to say it, towards each other. Okay. They intersect basically. Okay. So let's look at an example of that. So in the white here, I'm going to do it the first way. Okay. And then in the black down here, I'll do it the second way. So the first way is that you could break this one inequality into two separate parts. Okay. So the first part, one of the equations is this. Okay. And I'm going to use blue here. And the second inequality is this. Okay. So if I'm going to solve the first one, all right, and I can write it as a separate equation. Here, I need to subtract 4 from both sides. You get -2 is less than or equal to x. It's easier to read the inequality symbol from the variable side. So here you have x greater than or equal to -2. Okay. Now, second inequality is x plus 4 is less than 9. Subtract 4 from both sides, you get x less than 5. Okay. And again, if you need to cross the things off to help you keep track of everything, that's fine. So now I have two inequalities that I can graph on the same number line. And I'm just going to stick with blue for the graph. So for the first process, x greater than or equal to -2. So at -2, the equal to part is included in the inequality. So that means a closed circle. Okay. And the x's are greater than that. So I'm going to shade to my right. And I'm going to stop just short of 5. You'll see why in a minute. Well, I'm going to go all the way up to 5 because you'll see why in a minute. All right. And then this part says x less than 5. And I am going to change colors to red here just so you can see what I meant about the two parts intersecting. So that this doesn't have the equal to parts. And that means an open circle at 5. And the shading is to the left because it says x less than 5. So that means I would shade this way. So you see how but I'm bound by 2 on the other side. So you can see how the shading overlaps each other. And that's how you graph an and inequality. All right. Now we got to do our interval notation. It's a little bit easier. We usually only have one set of brackets and parentheses for our interval notation for and inequalities. All right. So you can see here my solution set starts at -2 and it's included. So that means I have to have a bracket. -2, comma, and then it stops at 5. But 5 is not included, so that means I need a parentheses. Okay. Now that's the first way to do it. You can do it into two separate inequalities, solve them individually, and then graph them on the same number line. Okay. Now the second way you could do it is, and this is the way I do it, but if you don't do it this way, it's fine. Whichever way works for you. Instead of doing it this way, because I might forget something here, I'm going to subtract 4. I said you could do it all at once, but whatever you do has to be done on both sides of the inequality. So it means I need to subtract 4 here, and I need to subtract 4 here. So that goes to 0 because I want only x in the middle. Okay, that's why I said you work from the middle out. 2 minus 4 is -2, less than or equal to x. And that looks just the same as this part up here. Then I have x less than 9 minus 4 is 5. And this part looks just like this up here in blue. So I have the same inequality that's underlined, not an equal to part. So I'm not going to graph it again because it would be the same graph. And you have the same interval notation. And that's how you work compound inequalities. Okay. So I passed out an assignment. Once you watch these notes, if you want to start working on that assignment, and then when we come to class on Monday, okay, I have some more problems for you and we can go through some more together if we need to. But that's all there is to solving compound inequalities, okay? All right, so I hope you guys have a great weekend and I will see you guys on Monday.